Good to see you all. Welcome to Unit 3, Lesson 11. Like usual, you're looking for the tasks for U3L11. You can find it under assignments or on the campus homepage in the weekly calendar. Today's date is the 16th. Remember to scroll all the way down because this is Sci2B. We'll start off with our usual pair and discuss and share. Today's question is a little more straightforward. What's your favorite breakfast cereal? So imagine if you were at a cereal party, which one would you go for? If you're not a big cereal person, then tell me what's another like breakfasty food you like. Are you a Pop-Tart person or like an English muffin person or oatmeal person, something like that. So think about that for 20 seconds. Also, make sure to say hi and check in with the person you're in a room with. We'll come back together in 2 minutes. Rooms are open. Everybody. Next on the list is homework check, as usual. Share my screen here for 2 seconds. You just had to make sure that you completed the classwork from our previous lessons. So make sure you've completed the Combined Gas Law Ed puzzle or the Google Form alternative and the Investigating Drinky Bird activity that we did. We're going to continue to study the Drinky Bird today. Homework was a quiz on the reading, which I pulled together in that Google Doc. Again, it's looking great, seeing 13 attempts. Pretty much 100% correct on each of the questions, seeing a couple responses that are incorrect. So just remember that you can always retake these quizzes. You have up to 10 attempts. So if you want to get that perfect score, you can take the quiz again. And it should tell you which question specifically you got wrong. And we'll show you the correct answer, but we'll tell you which one you got incorrect. And I'm impressed that a lot of people got the steps right, it looks like. That was meant to be one of the trickier questions. So questions or comments on those assignments? Wiley.
So for I think it was the second one and like the yes, no, or maybe. I took the quiz 3 times and I put a different one each time, but it said I got them wrong all 3 times.
Okay.
So,
Yeah, correct answer should have been no. That there's really, if you're talking about thermodynamics, there's really no such thing as a perpetual motion machine. Energy is always being lost. So yeah, and it's as far as I can see, it's marking the no as correct, which most people chose. So yeah, maybe take it one more time and mark the no. That should be the correct answer, but I'll try to remember to double check your score.
all right.
Yeah, the answer key thing does mess up sometimes. Anything else? All right, kiddos, let's see what you took away from this. We'll play a short little Kahoot that I pulled together based on the Drinking Bird. It's just 10 questions. All right, our game code is 754-4647. Please use your name or something close to it so we know who everybody is. All right, that's everybody. Let's do this. When water is applied to the spongy head of the Drinking Bird, it evaporates and does what? What does the evaporation do? Very good. Pretty much everybody got that. It cools the head by removing heat. It's the same way that sweat works. So think about the head of the bird as essentially sweating. The water's converting from liquid to gas. That's low energy to high energy. So it absorbs energy from whatever it's leaving. That's why we call it evaporative cooling. All right, Soph in the lead. As evaporation cools the head, the methylene chloride vapor in the head changes to liquid through what? What do you call it when you go from vapor to liquid? Interesting, we're a little torn here. So the correct answer is indeed condensation. Remember, that's anytime you go from a gas to a liquid. Vapor is just another word for gas. Evaporation is the opposite, where you're going from liquid to gas. That is occurring in the bird, but not during the cooling that's happening inside the head portion. All right, so still in the lead. True, false. According to Gay-Lussac's law, as the temperature in the head decreases, the pressure also decreases. Very good. Again, most of you got that. That is indeed true. The trick here is to remember that everything is proportional to temperature, right? So temperature and volume are directly proportional when you're talking about gases. Temperature and pressure are directly proportional. In other words, they'll always behave the same. Temperature goes up, pressure will go up, volume will go up. If temperature goes down, pressure will go down, or volume will go down. All right. The methylene chloride in the bottom bulb is constantly evaporating in a sealed space, which creates what? Evaporation in a sealed space. Very good. Wow, that was a fast one. Yes, so you are building up gas, vapor, right? Evaporation is creating more vapor, and if it's in a sealed space, you're creating high pressure, and that's what's going to push the liquid up. Well, I kind of gave away the next question, but hey, all right, Quinn pulled into the lead. The high pressure in the bottom bulb and the low pressure in the head bulb drives the liquid where? Very good. I basically gave that away, but it goes upwards, and we observed that during our experiments and in the video in our previous class. All right, Quinn in the lead. True, false. As the liquid rises up to the head bulb, the bird becomes top heavy, tips over. Very good. Hopefully that was an easy one. As it tips, the bottom tube rises out of the liquid, sending vapor to the head and pushing the liquid where? Very good. This is kind of the reset phase, right? So the vapor is finally able to escape from the bottom bulb and move to the top, and it sort of equalizes the pressure. But it does that more by vapor getting to the head portion and pushing the liquid back down. Okay, Quinn's still in the lead. As the liquid flows back to the bottom bulb, the bird becomes bottom heavy and does what? Very good. Another easy one. Oh, no one went with explodes. That'd be pretty crazy if it exploded. But yes, this is a reset. So when the liquid goes back to the bottom, the bird stands up again. Okay, true, false. Applying ice to the bottom bulb, making it cold, makes no difference, and the bird will keep drinking. Very good. That is false. A lot of you observed, hopefully, in our previous class, that if ice is applied to the bottom, it slows down the evaporation. You don't get that high pressure buildup, and so the liquid will actually just stay at the bottom. The bird won't do any drinking. Okay, Quinn's still in the lead. Last question. Applying ice cold water to the head of the bird will do what? Very good. Most of you got that. Again, that it will cool the head faster and make it drink faster. Even though technically evaporation would be a little slower with cold water, the fact that the water's cold, that cold temperature that it brings with it, that's what will cause condensation in the head bulb. All right, way to go, Quinn, Alex, Soph, Wiley, and Joyce, our top 5. Questions or comments on that Kahoot? All right. We're going to continue to further explore the drinking bird. Again, I saw a couple incorrect choices there, so I want to really make sure we drive this home. The best way to do that is, again, to work through an ed puzzle. You're going to see an engineer actually talk about how the drinking bird works and go into a lot of detail about what's happening and ways that you can mess with it, which is the activity we're going to do today right after you're done with this. So on the tasks to complete list, we are now on step 4, drinking bird ed puzzle. Go ahead and click on that. It's 9 minutes and 11 seconds long with 7 questions. I'm going to put 15 minutes on the clock, but I'll track your progress through ed puzzle, and once it looks like most people are done, we'll come back together to review. So 15 minutes to work on the engineering of the drinking bird ed puzzle. Let me know if you have questions or need help. From the base. And final question is, why does the drinking bird like to drink whiskey twice as fast? No one chose that drinking birds just like to drink whiskey. It is because the alcohol evaporates faster. And so this is something you'll be able to experiment with today. Any questions or comments on that ed puzzle? Okay, it's your turn now to do an experiment. I'm going to share my screen here for just 2 more seconds again. On the tasks to complete list, we are now on step 5, the very last one, drinking bird experiment. Whether or not you have the drinking bird toy, you can complete this assignment. When you click on it, it will take you to a quiz that looks like this. And so I've got instructions in 2 different colors for the 2 different situations. If you don't have the drinking bird toy, then follow the instructions in red. I basically created videos that you can refer to. If you do have the drinking bird toy, then follow the instructions in blue. So if you do have the drinking bird toy, you're going to need a few more things. You're going to need to set it up with a mug or a glass of water. You'll need a timing device of some sort, like your phone or something else. You'll need a water source. And then depending on the experiment you choose, you'll need a couple other resources. So you might need hot water, cold water, hand sanitizer. It's your choice in terms of what you want to do. So here's the gist of it. You're going to either watch a video of or set up your drinking bird and then just time it for 3 minutes. Once you get it going, time it for 3 minutes and count how many drinks it takes under normal conditions. So again, if you don't have the toy, you can just watch a video that I made of this and count, or you can do it yourself. I encourage you, if you have the toy, do it at home. Then you're going to do an experiment. You're going to change something. So you can either expose it to ice cold water instead in a mug or boiling hot water. You can heat the bottom using a blow dryer or a candle or a space heater or something like that. You can apply hand sanitizer to the head or isopropyl alcohol if you have that for like nail polish remover or something like that. You can use an electric fan to fan the top part, right? Or just do it by hand. I waved a Tupperware lid at it. And so again, if you don't have the toy, I've got videos of all of these experiments that you can watch. And again, you're just setting it up, and for 3 minutes, you're counting how many drinks it takes. If you have the toy at home, then set up and do one of these experiments. And again, the point is to then determine the difference, right? Did it take more drinks or less drinks over 3 minutes? So did it speed up or slow down? And then take your best guess as to why. And then there's the last question, sort of a check your understanding about how the drinking bird toy works. So I'm going to put 15 minutes on the clock to work through this. But again, I'll track everyone's progress through Canvas. And once it looks like most people are done, we'll come back together to review. Let me know if you need help or have questions.